Today we're going to talk about rational exponents. We have looked at radicals and roots, and there's an equivalent way of writing these radicals and roots using what we call rational exponents. So if n is a positive integer greater than 1, so n is like 2, 3, 4, and so on, and the nth root of a exists, in other words, it's a real number, we can actually take that root, whatever root it is, then a to the 1 over n, which is the rational way of writing rational exponent, a to the 1 over n is the nth root of a. So let's take an example. Supposing I have this 2 raised to the 1/2 power. What that is saying is that is equivalent to the square root of 2, because the index on this root is 2. If we don't write the index, we assume it's 2. So 2 to the 1/2 really is the same as the square root of 2. Or if I had 2 to the 1/3 power, which is a rational exponent, what does that mean? Well, what we're saying, this n, this number here, is the root. So this is actually the cube root of 2. And so this is a way of writing a root using an exponent. Now here are some more examples of rational exponents. Supposing I have y to the quarter, y to the 1/4, means the fourth root, that denominator is the root, the fourth root of y. Negative 9 to the 1/2. That means negative, this is the second root of 9, which is the square root, negative the square root of 9, which is going to be negative 3. 2 times x to the 1/3. This is going to be 2 times the cube root of x. Now, so far we've been looking at 1 in the numerator and all these rational exponents, but you could have other numbers in the numerator, and actually the number in the numerator is going to be the power on the variable or the number. So let's look at that. So let's suppose you have a raised to this rational number m over n, and let's assume m over n is simplified as much as possible. So the simplified fraction over here. M would be the power, and n is the root on a. So in other words, we're going to have the nth root of a to the m. Or you could actually do them in either order. We can have the nth root of a raised to the m power. Generally speaking, you'd want to use this form because it makes it easier to calculate. You take the root first and then raise it to the power. And we're assuming that the nth root of a exists, it's a real number, and also m and n are both positive integers greater than 1. So let's take some examples using this. So we have 4 raised to the 3/2 power. What does that mean? Well, that means the 2 root, the square root of 4, all cubed. And normally we go for the root first. So the square root of 4, all cubed. The square root of 4 is 2. 2 cubed is 8. Let's take another example. If we have negative 16 to the 3/4 power, what does that mean? Well, that means negative, because the negative is not being applied to the power of the root. It's the negative in front. But we have the 4th root of 16, and we're going to cube that. So what is the 4th root of 16? You might recall that 2 to the 4th power is 16. So this is going to be 2 raised to the 3 power. This is also going to be 8. Okay, what about if you have a negative rational exponent? If you have a to the negative m over n, it really means, remember, a negative exponent means flip it. So it goes in the denominator. It means 1 over a to the m over n. As long as a is not 0, as long as we make a note that a can't be 0, because then we would have 0 in the denominator, and that's undefined. So let's see, how do we use this? Well, if we have 16 to the negative 3/4, what that means is 1 over 16 to the 3/4. And again, we're going to take the 4th root of 16 and cube that. So that's 1 over the 4th root of 16, and we cube it. The 4th root of 16 is 2, so that's going to be 1 over 2 cubed, and 2 cubed is 8, so that will give you 1 over 8. So 16 to the negative 3/4 is actually 1/8. Now, we can use these ideas to simplify expressions, but let's recap our rules of exponents. Remember, a to the m times a to the n, the same base, you add the exponents. That's a to the m plus n. A to the m raised to the nth power is a to the m times n. You multiply exponents. When you have an exponent to an exponent, you multiply. A to the m divided by a to the n, you subtract exponents when you're doing a division with the same base. A to the m minus n. As long as a can't be 0 because you can't divide by 0. A to the 1 power just gives you back what you started with, a. Anything to the 0 power, a to the 0 power is 1, as long as a is not 0. So anything other than 0 to the 0 power is 1. A to the negative n power, the negative power means you flip it, is 1 over a to the n. So let's use this and then what we know about rational exponents to simplify a few expressions. So here we're asked to simplify a few expressions. We have x to the 1/2 times x to the 1/3. It means you add the exponents, so we'll have x to the 1/2 plus 1/3. And 1/2 plus 1/3, I'm trusting you can do those fractions. You'll have common denominator 6, so you have 3/6 plus 2/6, and that gives you 5/6. So this is x to the 5/6, which is the 6th root of x all raised to the 5th power. Here we have x to the 1/2 raised to the 3rd. So what do? When you have exponent to an exponent, you multiply the exponents. So this is going to be x to the 1/2 times 1/3. 1/2 times 1/3 is 1/6. So notice the difference here. Here we multiply the exponents. Here we add the exponents. This last expression, we're asked to do 2 times x to the 2/5 raised to the 5th power divided by x squared. Well, we multiply the exponents 2/5 times a 5th because we have x to the 2/5 raised to the 5th. So we'll have 2 times x 2/5 times 5th. 2/5 times 5, sorry. 2/5 times 5 is, the 5s are going to cancel, you get 2. So that's going to be 2x squared over x squared, because these will cancel like that when you multiply them. And then x squared over x squared cancels out because that's just 1, and we're left with 2. So that expression simplifies to 2. Sometimes it's easier to work with rational exponents than with the radicals. And so what we want to do with these radicals is convert them to rational exponents and simplify if we can. So here we have the 8th root of x to the 4th. Remember, the root goes in the denominator. So we'll have something over 8, and we have x raised to the 4th power. So this is x to the 4 over 8, which we can now simplify this fraction, which is 4 over 8 is a half. So we have actually x to the half, which is actually the square root of x. So even though it didn't look like the square root of x here, when we simplify, we see it's the square root of x. The second example, we have the root x times the 4th root of x. Remember, 4 is the index on the radical, so that's the 4th root of x. And so if I write it as a rational exponent, we can simplify. We have x to the 1/2 here times x to the 1/4. It's the 4th root is 1/4. So those are my rational exponents. And according to the laws of exponents, we add the exponents. So we have 1/2 plus 1/4. 1/2 plus 1/4 gives me 3/4. So this is actually x to the 3/4. If we want to write it back in the radical form, this is the 4th root of x cubed. Remember, 3 is the power, 4 is the root. So this is the 4th root of x cubed. Or you can think of this as the 4th root of x all cubed. So either way is fine.